This is the last lesson in the proof unit. So yay, we're almost done. It's about isosceles and equilateral triangles. So remember, an isosceles triangle has exactly two sides that are congruent. We learned that last lesson. There's something called the isosceles triangle theorem. This is like the big thing for today. Here's what it says. It says if two sides of a triangle are congruent, then the angles that are across from those sides are also congruent. So I think it's easier if we kind of draw a picture to say what this theorem is saying. And guys, let me just say, so we're going to say or, let me just say there are no proofs today. This is like actual math. There's numbers involved. This is fun. But let's rephrase this in a picture form. All this theorem says is if you have an isosceles triangle, so let me draw a picture, two sides are the same. I want to point out one thing for you real quick too. In an isosceles triangle, if you're looking at the picture like it's arranged right here, and the congruent sides are like the left and the right, this top angle between the congruent sides, that's called the vertex angle. That might come up one day. And then the two angles at the bottom, those are called base angles. So it's probably worth noting that here. But this theorem is saying if you have an isosceles triangle, then what do you know? Well, you know that the angles across from is what it's saying. These two sides are also the same. I just think of it as the two angles at the bottom are the same, the base angles. So if you look at this example here, and I always turn my paper so that way the congruent sides are like those two, the left and the right. So I would turn this example and look at it like this. If these two sides are the same, the angles below them are also the same. And they are the angles across from those sides, but I like to think of it like that. It makes more sense. So in this example, angle S and angle U would be congruent. All right, now notice that this theorem is a conditional statement. If this happens, then this happens. Remember when we learned converses. Converse is just when you take the hypothesis and the conclusion and you flip it. So the converse of the isosceles triangle theorem is just that same statement but flipped around. I guess we'll keep it so you can see it. I like the picture better, honestly. So this part would come first. If this situation's happening, where I have a triangle and I know these base angles are congruent, then it's okay for me to assume that those sides are congruent. That's what the converse is saying. If you see this picture, two base angles are congruent, you can assume that the sides are also congruent and this is an isosceles triangle. So an example here, this time they give you the angles and it's positioned the way I like to look at it with the angles like at the bottom. So I'm not going to move anything. I know that the sides like above those two angles would be congruent. So that would be PR and QR. So really, guys, you just got to get this picture locked down. If I got a triangle, it's isosceles, the angles below are equal to. So this is your big picture for today. If these are congruent, these are congruent. Now, there's something called a corollary, and you won't see this too much. We don't cover a ton of corollaries, but it's a corollary to this theorem, isosceles triangle theorem. And basically a corollary is just something that directly follows a theorem. I just think of it as a side note. So it's like, hey, here's this theorem, here's what it says. Oh, by the way, we forgot to mention this. It's just kind of like a side note to what we were just talking about. And this corollary talks about equilateral triangles. So this one says if a triangle is equilateral, isosceles is two sides are the same, equilateral is all three sides are the same. If it's equilateral, it's also equiangular, which means that all the angles are the same. Vice versa just means like if you flip it around, it's the same thing. Or the converse is also true. If it's equiangular, it's equilateral. a biconditional can be written out of this. I just said vice versa because I feel like maybe that might make more sense. But I like pictures, so let me draw a picture of this situation. They're saying if all the sides are the same, then you know that all of the angles are the same. And it works the other way too. So the vice versa just means, hey, if you know in a triangle that all the angles are the same, then you can assume that all the sides are the same. And fun fact, all the angles would be 60 if they're all the same. 180 divided by 3. Okay, turn it over. Let's do some real math. No proofs. This makes me happy. I get sick of proofs too, you know. I know you don't think I do, but I do. So let's see what we got here. Use the Isosceles triangle theorem, which is just this idea, along with the converse and the corollary, everything from the front to find the values of the variables. So you're going to have pictures that have more than one triangle. Focus and look for isosceles triangles. So I see one right there. If these two sides are the same, then you know that these base angles are also the same. So obviously that guy would be 70, which I don't really need to know that. I need to get over here to this triangle. So I'm kind of stuck, but I remember that angles right next to each other like this, they make a line. 180. So this guy over here would just be 110. Now, if I look at this triangle that y is in, and I'm going to turn my paper so you can see it the way I'm looking at it. This triangle right here is also isosceles. It's like this. So I know that these base angles have to be congruent, and I know the vertex angle is 110. So these two are the same. So 110, I'm going to do 180 minus 110. Don't need my calculator, but at least you can see a visual, which hopefully will be helpful. I know when I take off the vertex angle, I know there's 70 degrees left in this triangle. And if these two base angles have to be the same, I'm going to split that 70 into 2. And both of those angles would be 35. So I have y. All right, the next one uses the converse. So I see that these base angles are marked congruent, so I know then that those sides are equal. Don't overthink it. Literally just set those equal. Everybody should have an okay time solving this now. Just a two-step equation, so x would just equal 2. On example 3, there's a lot of marks here. There's several triangles. What pops out at me is the whole triangle is isosceles. Ignore all the stuff in the middle where x is. So this is the whole picture. I know that these two angles would be congruent from the isosceles triangle theorem. So this would be 25 over here as well. I could do a couple things now. What I'm going to do is just find the whole vertex angle. So I'm going to do 180 minus 25 minus 25. This top angle would be 130. And these are marked congruent. Actually, this picture is terrible. This mark shouldn't be there. I think they just had that there to like show you that's the angle they were talking about. They're not marking these like all three of these are the same. Ignore that. These two are the same. So I can go ahead and do 130 divided by 2 because x is just half of that. So x would be 65. Yeah, this is a bad picture. That little mark wouldn't be there if you saw this on any kind of assessment. All right, I want you guys to try number 4. And then number 5, I'm going to go ahead and do this one. There's 3 triangles I see here, so I'm going to kind of look at each one individually. What jumps out at me right away is this one in the middle. That one is equilateral. All the sides are marked congruent. So the corollary is going to come in right here. If all the sides are the same, all the angles are the same. and they're all 60 every single time in an equilateral triangle. Okay, so you can always just fill that in real quick if you see equilateral. How's that going to help me from here? Okay, if you don't remember this, you're going to get stuck. If you don't see this, these three angles together make a line. 180. So take 180, subtract off 70 and 60, and whatever's left over, that's 50 right there. I guess I could have found x right away. Let's go ahead and do that one while we're looking at it. I'm going to turn my paper upside down. Hopefully you can see that that's isosceles. So there's the two congruent sides. Below it, those are the two congruent angles. Since that guy's 70, this is 70. So I'm just going to do 180 minus both of those 70s. X would be 40. Now jump over here for y. That triangle is also isosceles. And we figured out that the vertex angle was 50. Okay, if those sides are the same, those angles are the same. So there's 130 degrees left in this triangle. I'm going to split it into two. And that would be y, 65. All right, last one. Find the values of x and y if the perimeter is 26. Perimeter just means you add all the sides up. All right, this triangle is isosceles. And I know that if I turn this upside down, I always like to look at it where these are the congruent sides. Both of these base angles are 43. So if those angles are congruent, these sides are congruent. So people might try to do this. They're like, oh, I know these sides are going to be congruent, so let's set those equal. But you can't do anything with that because it uses x and y. So you need to use this information somehow. They're not going to tell you this for no reason. They're telling me if I add all the sides up, that's 26. So I'm going to do x plus 3y plus y plus 3. When I do that plus that plus that, I should get 26, the perimeter. Okay, let's simplify this a little bit. X plus 4y plus 3 equals 26. I like that better than what I originally wrote. So this is now a system of equations. I'm going to use, oh, I could have subtracted the 3 over 2, but that's okay. We'll deal with it. I'm going to use substitution. So if you forget how to do substitution, here's what you do. This is set up nicely. X is the same thing as y plus 3. So I'm going to come down here, and I'm going to plug in y plus 3 where x is. So I'm going to rewrite this second equation. So instead of x, I put y plus 3. The rest of it was the same. Now I'm going to solve this for y. So when I combine the y's, that's 5y. I'm going to combine the 3's too. 5y plus 6 equals 26. We shouldn't have any problem solving this. Y would equal 4 when you solve that two-step equation. Once you have one variable when you're solving a system, you always bring it back up to the top to what you originally wrote and go to where the variable was alone. I know that y is 4, so 4 plus 3 is 7, which would be what x is.